Last episode, we said memory features paste facts about you into the context window. There's a more general version of this pattern, one that lets the model retrieve real information instead of relying only on what it was trained on. It's called RAG. RAG stands for Retrieval-Augmented Generation. The name is precise. There's a retrieval step, then there's a generation step. RAG just means doing them together. Here's the problem RAG solves. Remember from episode 3, once a model is trained, its weights are frozen. So its knowledge has a cutoff date. The base model doesn't have access to events after its training cutoff, unless a system provides that information at runtime. It also doesn't know your company's internal documents, your codebase, or your private notes. It only knows what was in its training data. RAG works around this, without retraining the model. The trick is in 3 parts. First, you have a corpus, a pile of documents that contain information the model needs. Could be the live web, could be your company wiki, could be a folder of PDFs. Second, when a question comes in, a retrieval system searches that corpus and finds the most relevant chunks of text. We'll dig into how it does that in a future episode. For now, think of it as a really good search engine. Third, those chunks get pasted into the prompt before the user's question. Then the model is asked to answer the question using the retrieved chunks. It's reading them in real time and generating an answer based on them. The model isn't recalling anything from memory. It's reading what the system just gave it. This is huge because it works around a few of the model's worst limitations. Knowledge cutoff, reduced. The corpus can be updated this morning, and the model can use today's information if it's retrieved. Hallucination risk, reduced. If the model has the actual document in front of it, it's much less likely to make up an answer. It can quote, summarize, and cite. Custom knowledge enabled. You can point a RAG system at your company's docs, and the model can answer using those docs, without retraining. But, and this is the precision pass, RAG is not perfect. It can fail in 3 specific ways. 1. Retrieval failure. The search system might not find the right chunk. If you ask, what does this policy cover, and the relevant section is buried under a different title, the search might miss it. Bad retrieval, bad answer. 2. Chunk failure. The retrieved chunk might be wrong, outdated, or contradictory. The model will often use it anyway, because it's in the prompt and strongly influences the answer. This is how RAG can confidently produce a wrong answer using stale data. 3. Model failure. Even with perfect retrieval, the model can ignore or misuse the chunk. It might overweight its own training, or paraphrase the chunk inaccurately, or hallucinate a citation that isn't actually in the source. Where you've already seen RAG, tools like ChatGPT or Claude with web search, that's a form of RAG. The web is the corpus, the retrieval is a search query, the chunks are page snippets. Custom GPTs with uploaded documents. RAG. Enterprise AI assistants that answer from internal wikis. RAG. So here's the picture. The model is the generation engine. The corpus is the source of truth. The retrieval system is the librarian that fetches the right page at the right moment. RAG is the pattern that ties them together. To recap, RAG retrieves relevant text from a corpus and pastes it into the prompt before the model answers. It works around knowledge cutoff, reduces hallucinations, and adds custom knowledge, all without retraining. It can fail when retrieval is bad, the chunk is wrong, or the model ignores the chunk, and you've been using it without knowing. Next episode, you now know how the machine thinks and how to give it information it doesn't have. There's one more thing, how to actually talk to it so it does what you want. That's prompting. If this was useful, subscribe. It tells me to keep making them. See you next episode.